52 and beyond. Okay. This is one of the first ones that we looked at. I really just wanted to make sure like we super formalize it, made our lives really easy. It kind of comes from this, the fact that as we go to 0, that the sine of theta over theta is just 1, right? We can just kind of pull that out. And so if you have stuff being multiplied through, then just multiply the numbers. Don't worry about the sign, right? If you had like a constant times sine of whatever, all stuff being all multiplied, just take the numbers. It should make your life a whole lot easier. So those two kind of go together. And then we looked at this one yesterday. 1 minus cosine theta over theta. That one was 0. I know that proof on like watching it from home was probably a little brutal to try to follow along. But hopefully like the idea of how I did it kind of stuff, right? We had some function up here, we had some function down here. We squeezed one in between and they all kind of met in the same spot. I did it a little bit better during fourth, I think, than I did with you guys. If you really want to know how to prove that first red one bottom left, you can rewatch it. But now we don't have to. Okay. And so I would love for you to just kind of jump in, right? And I'll guide you along. I'll stop at some of the important ones for sure. But I'll tell you this: 1, 2, 3, and 4 should be pretty easy. If you can just plug it in, then just plug it in. But if it looks like the thing in blue there, like number 2, number 3, and number 4, split the numbers and simplify that fraction. We did 5 together. Yes, yes.
I was kind of just like online, you know,
yeah.
I was kind of confused why that one and that one.
Why they're not both 1 or both 0. So when we did this one, that was the one with like the unit circle, and I created like those compound inequalities, and I just kind of messed around with the outside functions to make them both 1, and I squeezed sine theta over theta in the middle, so it was 1. But this one, I can do this one again, just so you can see it. And this is actually a really helpful strategy that you're going to start using, and we did start using like on number 5, like searching for some of these really nice, like the 2 red inequalities. And what we did to prove this one is I just multiplied by the conjugate, top and bottom. And I mean, I don't know if this is what you really want to see, but I mean, the short answer is they're 2 different functions that just have 2 different limits as we approach 0. It's just 0 over 0 and 0 over 0. So they're both holes, but that hole's location is just in a different spot because they have different functions. But the way that it worked out is like we got to the point where we multiplied out the top. Oh, I did something wrong there. Sorry. 1 plus cosine theta on the bottom. Right, multiplied by the conjugate, top and bottom. That just made it easier. And then I just left the denominator factor. I rewrote that top part using a trig identity, right? I did the Pythagorean one to give me the sine squared. And then, and here's the big thing that you guys really need to take away. If you want like 6, 7, 8, 9, 2, 5, 6, all of those to work. What I tried to do is I tried to look for this limit. Really, what I'm trying to see if I can find is this fraction. And what I noticed about my setup is that I had this one fraction. And what we know about fractions is that if I'm taking 2 fractions and I'm multiplying them together, I just multiply the tops and multiply the bottoms. So if I can multiply fractions together that way, I can break them apart in the same way. And that's something that you're going to want to start looking for, is ways to break one fraction into 2. If it's connected by multiplication, then connected by multiplication. And break apart the top and the bottom. If it's connected by addition, and we'll probably do one like that today, then I just break it apart with addition, but I keep the denominators the same. Like sine of theta squared, right? Because that's what sine squared is just 2 sines being multiplied together. I can tear them apart. And why I do that because the first factor on the bottom is theta, the second factor on the bottom just happens to be 1 plus cosine of theta. And there's that limit that's 1. We proved it, now we're going to go looking for it. And so the biggest takeaway from this, and I said it a lot, but I want to make sure that this makes sense. The limit of a product, things being multiplied together, is the same thing as taking two separate limits and just multiplying them together. I can take the limit of the first one and multiply it by the limit of the second one. The limit of like two things being multiplied together is just two limits multiplied together separately. But I can take the limit of that first piece and then the limit of the second. It's just a property of limits that works really nicely in our favor, cosine of theta, because this is 1. And once I have that, then I can just drop in 0 up top and on bottom and see what I get. Sine of 0 is 0, and so 0 over 2, 1 times 0 ended up being 0. Which is why this limit, the limit as theta goes to 0 of 1 minus cosine of theta over theta is 0. So we just have two different ones, two different functions. We just have holes in a couple different spots. But like the huge, huge, huge takeaway from this, number one, I need to retrain the way you think about math. Things work differently once you get to calculus, and we start rearranging things to work better for us. But the other thing that I want you to see is that there are really nice techniques that we can use over and over and over and over again. But I'm like, I just want to look for these two. And these are the two most important trig limits that you'll ever need. But those are ones you have to know and have to know how to go find. And I just did it like that kind of third line to the fourth line, breaking one fraction into two, and then breaking the limit apart into two different limits is going to come in super, super, super handy. Now, I know we did number 5 together. Let's just do another one so you can see it. Turn to page 53. Let's just do another one. Like I said, 1, 2, 3, and 4 on page 52. Really straightforward. The first one, you just plug it in. 2, 3, and 4, just use this idea right here. But let's do it some stuff together. So let's do 6 together. Okay. And what I want you to, you don't have to have it memorized yet. I want you to have those two limits either stuck up in your brain or at least somewhere close by, the sine of theta over theta being 1 and the 1 minus cosine of theta being 0. And all we want to try to do is go searching for them. I want to rearrange some stuff to see if I can find those limits. Okay. Now, they might not appear right away, so we might have some reorganizing to do. And this is the kind of thing that you just want to take a step, see where it takes you. Take another step, see where it takes you. We're going to factor, we're going to multiply by conjugates, we're going to break fractions apart, we're going to do whatever we can to try to just make things look better. And of course, if I could just plug numbers in, I will just plug numbers in. But obviously, we can't plug in 0 right here, right? Because we'd be divided by 0. And so anything, is there anything up top that you see that could be a decent start? Even if it doesn't magically give us the answer right away, that's why these boxes are pretty big. And I'll tell you what, usually I'm filling them. Most of the time, I'm taking lines and lines of work. Sometimes I'm not, though. Right on that first page, things are simpler, so I don't need quite as much space. But you'll see in like page 53, some of this stuff on page 54, but then like the bottom right one, didn't need all that space. And we just don't know until you get started. Okay, so anything, what do you see? Anything up top and on bottom that we can do? So I see cosine squared, okay. What do you want to do with it? 1 minus sine squared, okay. Before we use that identity, let's factor out the 2 and then see if the identity pops up even faster. So factoring is a really good way to start because I think it's gonna get us to the same spot, but even faster and simpler because look at the two. 1 minus cosine squared theta. Like look what's right there already. What is 1 minus cosine squared? It is sine squared. And so instead of making the change to 1 minus cosine squared, or 1 minus, and then multiplying a whole bunch of stuff out, we can just write it right away by factoring. Now, if that was just sine of theta, then there's my limit, right? Sine of theta over theta. That's what I'm looking for. But it's not. It's sine squared. But I really like the fact that there's only one term up top, one term on the bottom, because maybe now there's something we can do to try to isolate the kind of limits that we now know are good ones to look for, sine of theta over theta, or 1 minus cosine theta. I'm going to come down here just to give myself some space to work. You probably can write a little smaller than me. Can we break this apart into two fractions being multiplied together, just like we did on number 5, and just kind of like I did on that last proof, where the sine of theta over theta is just one of those fractions? Absolutely. I can pull that piece out. If it's a common factor, it's just like we're kind of like factoring out a fraction that we really like. That's what we're going to go searching for, that kind of fraction that does what we want. Okay, well, what's left up top when I pull out sine of theta? 2, and then another sign, right? The 2 from the leading coefficient, and then another sign because it was sine squared. Okay, what's left on bottom? Just 1, right? Because it was just theta. And I factored it out, so all I have left behind is a coefficient that was attached to it. And the thing that we want to start doing is showing this step. The limit of a product is the product of two limits. Or if there were 3 fractions, I break it into 3 limits. If there were 4 fractions, break it into 4 different limits and deal with each one kind of separately. The limit of the first one, sine of theta over theta, times the limit of the second. I don't need the fraction anymore, it's just over 1, so the limit of 2 sine. What's so nice about that? Why? It's just whatever 2 sine of theta is because this is 1. And so all I have to do is 1 times whatever that limit is. There's no fractions. I don't have to worry about doing anything but plugging it in. And eventually, that's always the last step. Get yourself to a point where you've either like divided away the problem by factoring and simplifying, or rationalizing and simplifying, or isolating one of those, or both of those 2 trig functions, 0, right? Because 1 times 2 times 0 . Yay, 0. I got it right. Cool. Okay, so that's just kind of like some of the ideas you want to have. And if you're saying to yourself, man, I really don't know how to start some of these problems, that's the point. It's not always going to be step 1 is do this, and then step 2 is do that, right? We're not, factoring, and we're not plugging stuff into the quadratic formula. We're analyzing. And that, like, calculus is a very different mindset. But step 1 is up to you. And it really kind of depends on what things look like. And so I want to do 7 with you as well, just so you can kind of see that. And maybe then I'll give you some freedom to try some of these on your own. And don't stress about them being perfect. Don't stress about getting every single one of these correct. It's probably not going to happen. And hey, if we need the weekend to finish this, no big deal. I am not stressed about getting this done today and tomorrow, especially with us losing 11 minutes out of class today that we otherwise would have had, right? Classes are 39 minutes long today. I love it, though. it's so beautiful. All right, let's do it.
I don't like snow.
I know. To each his own. All right, look up top. Are things being multiplied together anywhere? So then don't try to factor things apart. If things are connected by multiplication, then split it into multiplication. How are all of your terms up top connected? Addition and subtraction. So let's let's see if we can break fractions apart that are just with addition and subtraction, keeping in mind the kind of limits that we're trying to isolate. Those three on the left. Right, some combination of sine of theta over theta with numbers, that's cool, or a 1 minus cosine theta over theta. Those are the kind of things we're trying to look for. And so, do you notice anything kind of standing out to you? Maybe like a certain fraction that we can pull out, and then we'll just connect the other one with addition or subtraction, not multiplication. One minus cosine theta over theta. That's perfect, right? There it is, right out front. And so what I want you to see is like when we break fractions apart with addition or subtraction, remember that the denominator just stays the same. Right? If I want to combine fractions, what do I need? Common denominator. Okay, so if I want to break fractions apart, they better have the same denominator to do that. And so now we already used the 1 minus cosine theta. So what do we have left? We have sine of 2 theta. Put parentheses around it because you want to take the limit of all of it. Otherwise, you would just have the limit of the first fraction and the second fraction we would know. But just like the limit of a product is a product of limits, I can break it apart into as many things being multiplied. Same thing with addition subtraction. The limit of a sum is the sum of those limits. And by isolating each one, then you can lean on one of those really nice proofs, or one of those really nice kind of prove-in, I should say, limits. And what it's not easy necessarily to know what to do first sometimes. I first took calculus 18 years ago. I've been doing this a lot longer than you have, and it's just that's all it takes is a little bit of experience, plenty of failure for sure, and some confidence when you get some success. Okay, so what's that first limit? 0. What about the second one? It's not exactly sine of theta over theta. It's sine of 2 theta over theta. Top left. Whatever your numbers are that are being multiplied through that really nice sine of theta over theta kind of setup, you can pull those out. You don't have to worry about doing anything but saying, oh, there's a 2 on top, right? A 1 on the bottom. Consider that quotient, whatever that fraction is. If it was like 3 sine of 2 theta, okay, 3 times 2 over 1, right? Just multiply all the numbers on top, multiply all the numbers on the bottom, see what you get. 0 plus 2. Okay. Now, we are here until sometime. Let's see, it was 39 minutes and we started at what, 54? Yeah, so 33, we're out of here. So that gives you about 20 minutes to just start some of these. And when you get stuck, ask me, ask the people around you. This does not have to be a super individual kind of thing. But it's the kind of thing you have to try, see how far you can get, fail, try again, ask for help. If you just watch me do it, you won't learn. And I don't care if you get these right. I really don't. I care that you try them and ask for help when you do. Okay? And I don't care what order you go in. I would probably back up if you haven't done 1, 2, 3, or 4 yet. Those are the simplest ones for sure. You can get started with those. I will pull up the solutions to those so you can see that you're getting them right. Questions though? Did that make sense? Okay. And so talk to me if you need me. Otherwise, do your thing, get some work in, and then we'll finish up as much as we can tomorrow. I'll probably just push it till Sunday. I don't care. Sunday night. Let's make this thing do Sunday night. So if you need some more time this weekend to finish up some of the trickier ones or ask questions or get help, you got plenty. I want to scroll if you have, yeah, go ahead. What's up, Colin?
On 8,
Yeah.
would you want to like cancel the secant?
So you can't cross out the cosecants or the thetas yet because they aren't being multiplied everywhere. I can't factor it out and then divide. All right, you can't divide away. You can't cancel things that aren't connected by multiplication. The +1 is addition, right? And so what I did to try to do exactly what you thought, right? Man, I see the thetas up top. I see the cosecants of theta. I would love to cancel those out. Well, let me break those fractions apart and simplify. So I wrote, so same denominator. I took this plus and I put it right here. The first piece right there, the second piece right there. Then you can divide away. So that's definitely a good idea. Trying to look for a way to divide stuff away. But you have to create monomial tops and bottoms. And that second fraction worked out amazing. 1 over theta cosecant theta. Well, cosecant is the reciprocal of sine. So let me move the cosecant from the bottom to the top and call it sine. That's the reciprocal, right? Moving from top to bottom or bottom to top and writing the other way. And sometimes they use theta, sometimes they use x. I think they're just trying to get us used to seeing both. Something like 8 and 9. 9's awesome because we actually find both of those ones. Right, the sine of x over x and the 1 minus cosine of x over x. And so seeing x squared as x times x, right? Seeing sine squared of theta as sine of theta times sine of theta, that's going to be really helpful for you in trying to figure out good ways to get these kind of problems done. But yeah, ask questions. Let's talk through any of these that you want to see. And I don't know if it's better to just put up the answers or to actually walk through them. From here to here. Yeah. So cosecant is the reciprocal of sine. And so here's kind of what's happening in the background. So if it was just 1 over cosecant of theta, without the theta in the beginning, do you agree that that's sine of theta? Because they're reciprocals of each other? Okay. Still equal, right? That's kind of what my thought process was. Is that if it's together as one fraction, well, I can just kind of consider them separately. Keeping the theta on the bottom, obviously going to be really important because that's not really part of cosecant of theta. It's just being multiplied through. And so I just took the trig part and made it nicer, right? Rewrite it in terms of sine and cosine. I just didn't bother going like this first, just to do this to move it up top. But that's what I'm doing. Yeah, that's what I'm in that very first line. So like from the one that Dave started with to my next line down, I factored out the common factor, which was sine of x. Yeah. So I pulled that out, and I wasn't sure what it was going to give me. But once I did, I was like, oh, there it is. That's perfect. There's a sine factor and a 1 minus cosine factor, which means I can break those fractions apart using each one. And again, remember, when you break things apart with multiplication, you have to make sure that if you multiply the top and the bottom back together, it would be correct. If you're going to break things apart with addition and subtraction, you have the same denominator all the way through. Again, parentheses around any sums or differences that you have, and then take the time to actually write the 1 limit as 2 before you evaluate. And we'll keep practicing with this. I want to wrap up chapter 1 on Monday with just kind of a nice kind of like wrap up idea. But then like Tuesday for sure, we'll definitely review everything. Like I'll go back, I'll make a review, kind of some sort of like chapter 1 study guide. I haven't decided exactly how I want this to go down with the chapter 1 test. Kind of wish we had Friday in school, but I don't know. Have not decided yet. So either like want everybody to take it in school or everybody to take it at home. Like I don't want to go to Thursday and you guys are here and they're at home. So I just don't think that that's equitable for the kind of resources that maybe you'd be relying on. So or like the time freedom to do it when your brain is most ready for calculus. So I may push it till like Friday, and then you can do it whenever on Friday. Would that work for everybody if I did like an at-home thing? I want to start doing some in-class testing so that you're used to that experience again. Actually, like prepping for a math test, but I don't know. I don't know if I want to rush it to like Wednesday, Thursday, or if I'd rather just give you some more practice, make sure you're really confident in what you're doing, because a lot of this stuff is new. So I'm leaning towards that. I'm leaning towards we'll take some time to review in class, and then I'll send you home on Friday, and I'll send it out to you Friday morning. This way, kind of just a fresh start, chapter 2 next the week after that. So what is that? Friday the 26th. So let's say tentatively a week from tomorrow, chapter 1 test. At home, definitely, I'll send it out with the Google form. So if there is some multiple choice, you just kind of click through that. And if there is some work required, just like our quiz. And if there's anybody that wants to talk through your old quiz before that, I think that's a good idea. If you didn't, even if you just got anything less than a perfect score, I think it's worth talking about so you know where you can improve if that's something you'd like to look at. And we can do it during some common free time when you're in school, or we can set up a Google Meet at home, or whatever. I'm happy to be flexible. How it works for you. So that's the last of that section. That kind of turns the page and has us getting into some other ones. Should I scroll? You guys ready to see some more? I don't know. It's up to you. If it's helpful. I put 3 on there just so you can see it. I can't quite see it just yet. I'll leave 1 and 2 up. But something to practice, something to just get better at for sure, dealing with piecewise functions. I just called it all f of x, so I could just say limit of f of x and have to keep writing it over and over and over again. If you say limit as x approaches whatever, but you don't tell me what you're taking the limit of, it's like writing a sentence without a noun in it. That's just incomplete. So you want to make sure you're writing those 4 things out. But lots of different strategies, so I know that can be a little tricky. So try it out, see what you think. Folks at home, let me know if you need anything, want to see anything. A big takeaway from me on number 1, if you just want to look up for a quick second, look what the theta is approaching. Just not 0. If it's not 0, I'm not looking for those limits. Right? Those are very, very, very specific limits. As limit as x approaches 0, theta approaches 0, with the whole sine of x over x, or 1 minus cosine of x. So if it's not going to 0, you know what not to look for, and it kind of just narrows down your choices for how to do it. And so I just went for like a single trig function, get it everything in terms of sine. Oh, difference of squares. Oh, divided away. Oh, I can just go. But like 2, and 4. Oh, I know exactly what I'm doing. Last few minutes, so get yourself to a decent stopping point if you'd like it. Like I said, about 3 minutes left. We're at 33. So get yourself to a decent spot. Pause for now, and then I will see you virtually tomorrow. Folks at home, I will see you guys back in person tomorrow, and we'll just finish the work. We made some good progress, and I don't know. You tell me, like, do you get it? Right? Do you have like a good idea of how to start looking for things? And I feel like we're just like adding all of these really nice tools to your imaginary calculus toolbox. You know, sometimes we'll take out the calculus chisel, just knock away at it. Sometimes we take out the algebra jackhammer and just brute force the thing. You guys should work. Bottom of 3, yeah. Yeah. So piecewise functions, I always just check the left side and the right side, compare them. If the left side and the right side have the same limit, then limit exists. And is that? That's the thing. They put a question like 3 and 4 next to each other. I needed all the space for number 3, and I needed almost none for number 4. So that's going to happen. So don't get initially fooled by the size of the spacing of every single box, but it usually is a little kind of an indication of how much work you might need. But these are lots of really good practice. So, and you'll see that after page 57, like the very, very back page, front and back, is just some more multiple choice practice on all kinds of stuff. This is actually like the multiple choice practice that they provided for us for the chapter 1 test, right? How I gave you those practice quizzes, there is the multiple choice practice for the test. So, but you'll definitely get more review from me for sure. You know, make copies of their practice whatevers and give it out. See you next week. And we'll just, I don't know. We'll see how it all plays out. But hopefully, you'll feel confident going into next Friday. And we'll just kind of Oh, it's because, so I graded them. I didn't put them in yet. So they're all graded. I can put them in. Yeah, I will do that today for sure. Sorry about that. I was waiting for some folks that didn't take it over the weekend, and they did. So we're good. We're all caught up. I will put those in today. Thanks, everybody. Have a good day. I will see you, what's today? Thursday. I'll see you Tuesday? What day is it? Today's Thursday? Now, remember, we have school tomorrow. You guys get to be virtual. Cohort A, I will see you in person tomorrow. Any questions? Anything? All good?
Thank you.
Welcome. See you. Thank you. See you guys.